Hi everyone, and welcome to Chapter 7 of Exploring STEM and Coding with EDU PICO. In this part, we will learn to program EDU PICO to control a DC motor, spinning direction and speed control. DC motor is a component that converts electric energy into motion. It can power an array of mechanisms from spinning wheels to robotic arms. Connect DC motor to M1A and M1B terminals as shown here. Press the M1A and M1B buttons to test the motor. If the motor is not spinning, make sure the wire connection at the terminal is secure and EDU PICO is powered on. After completing this activity, the DC motor speed will be printed on the shell console. It then continuously rotates at a different speed and direction, starting from reverse direction at a 50% to 25% and to a halt at 0%. Then it proceeds to forward direction of 25% and 50% speed. Each speed will last for 2 seconds. Then the cycle repeats. Let's begin with writing the code for this activity. Line 2, PWM I/O module allows the control of PWM output. Line 3, Adafruit motor module provides motor control functionality. Line 5 to 6 initializes two PWM outputs to control the DC motor, PWM M1A and PWM M1B on GP10 and GP11 pins respectively. The frequency parameter is set to 10,000 Hz, which defines the frequency of the PWM signal. Line 7, an instance of a DC motor is created using the motor DC motor class. This instance is named motor and is configured to use the PWM M1A and PWM M1B PWM outputs to control the motor. Line 8, a list called speed mode is created, which contains a set of speed values. The values in this list range from -0.5 to 0.5 with a step size of 0.25. These values represent different speed settings for the motor, ranging from 50% reverse speed to 50% forward speed. Line 11, a for loop that iterates through the elements of the speed mode array. Line 12 to 14 prints the current speed percentile to the console and sets the throttle of the DC motor to the current speed level. For example, in the first iteration, the speed is set to -0.5, which means reversing at a 50% speed. In the second iteration, the speed is -0.25. So it's reversing at 25% speed. By the third iteration, the speed is 0, which means stopping completely. After arriving at the final element in the array, the for loop will reiterate to speed -0.5. From the previous chapter, we have learned how to operate the potentiometer module on the EDU PICO. Now, it's time we make use of that knowledge in this mini activity. Let's program our EDU PICO to control the DC motor speed using the potentiometer. Let's give it a try. This is the complete code for the activity. There are two DC motor terminals on the EDU PICO board, which means you can connect two DC motors and control both at the same time. If you haven't noticed, the EDU PICO has a built-in motor test circuit that allows you to check the connected DC motor in forward or reverse direction. Converting a DC motor into a vibrating haptic feedback device is one of the many popular applications of a DC motor. Haptic feedback is a technology that enriches user experience by providing tactile sensations in response to digital interactions. For example, the micro vibration you get when typing on a smartphone. Well done completing part 1 of chapter 7. In the next video, we will explore the relay. Thanks for watching, and I will see you in the next video.